Hello viewers, in today's session we are going to discuss another important and conceptual problem from definite integrals, and in this class we are going to evaluate this definite integral that is from minus 2 pi to 2 pi, and here we have a mod of 2 pi minus a mod of x and dx, right? So let us see how we can easily evaluate this definite integral by using two concepts. The first one is the definition of mod function, and the second one is the property of definite integrals, right? So let us start, and let us first call this integral as I, right? Now see here the limits of integration are from minus 2 pi to 2 pi, right? And the integrand is the integrand is f of x, and it is mod of 2 pi minus mod of x, right? So here first of all we'll make use of an important property of definite integrals, which connects the concept of even functions, right? So here we have minus a to a, and we have a function say f of x dx, and the value of this integral that is from minus a to a f of x dx is equal to 2 times the integral from 0 to a f of x dx, provided this integrand, that is this function f of x, is an even function, right? So a function is said to be an even function if f of minus x is equal to f of x, right? So if we replace x by minus x in this function f of x, and the function remains the same, then the value of this integral, that is minus a to a f of x dx, is equal to 2 times the integral from 0 to a f of x dx. So first of all we'll apply this property to this integral, right? So here if we replace x by minus x, then we have f of minus x, and here we have mod of 2 pi minus mod of minus x, and we know that a mod of minus x is equal to simply mod of x, right? And here we have mod of 2 pi minus mod of x, and which is simply the function f of x, right? So we can see that our integrand mod of 2 pi minus mod of x is an even function, right? So we can now write this integral I as 2 times the integral from 0 to a, and here the value of a is given by 2 pi. So we have 0 to 2 pi, and here we have simply a mod of 2 pi minus here we have mod x and dx. So now we have to evaluate this integral, right? And here we can see that we have a mod of 2 pi minus mod of x, right? So let us apply the definition of mod function. Now see, a mod of x is defined as positive x whenever x is greater than 0, mod of x is 0 when x is equal to 0, and mod of x is negative x when x is less than 0. And see, here the limits of integration are from 0 to 2 pi, right? So when x belongs to this interval, that is from 0 to 2 pi, then we have all the values of x as positive, right? So when x belongs to this interval, that is from 0 to 2 pi, then all the x are positive numbers, right? So mod of x must be equal to positive x, because x is greater than 0. So here we can now replace mod of x by positive x. So we have 2 times 0 to 2 pi, and here we have mod of 2 pi minus mod of x is replaced by positive x. So we have mod of 2 pi minus x dx. So now we have to evaluate this integral 0 to 2 pi mod of 2 pi minus x dx. So let us again apply the definition of a mod function to mod of 2 pi minus x. Now see, x belongs to this interval, that is 0 to 2 pi, right? So whenever we take any value of x which belongs to this interval, then 2 pi minus x is always greater than 0, or in other words we can say that 2 pi minus x is a positive number for all values of x belonging to this interval. And when we take x is equal to 0, then we have 2 pi which is obviously greater than 0, and when x is equal to 2 pi, then we have 2 pi minus 2 pi, that is 0, right? And in that case 2 pi minus x is equal to 0. So we can now apply the definition of mod function. So mod of 2 pi minus x is equal to positive 2 pi minus x whenever 2 pi minus x is greater than 0, right? And mod of 2 pi minus x is equal to 0 when 2 pi minus x is equal to 0, and this is mod of 2 pi minus x is equal to negative of 2 pi minus x whenever 2 pi minus x is less than 0. So from this part of the definition, we can see that mod of 2 pi minus x is equal to positive 2 pi minus x when minus x is greater than minus 2 pi or x is less than 2 pi. Right? So whenever x is less than 2 pi, mod of 2 pi minus x is equal to positive 2 pi minus x, and our limits of integration vary from 0 to 2 pi, right? So now we can replace here this mod of 2 pi minus x as positive 2 pi minus x dx, and now we can easily find out the integral of 2 pi minus x. So we have here the integral of 2 pi dx as 2 pi x and x dx as x square over 2, and the limits of integration are from 0 to 2 pi. So now we can simply substitute the limits and we'll take the difference. So when we take x is equal to 2 pi, here we have 4 pi square, and then here we have 2 pi square, that is 4 pi square over 2, and when we take x is equal to 0, then both these terms reduces to 0, so we have 0 minus 0. So now simplifying this term, the value of this integral I is equal to 2 times, here we have 4 pi square, and here we have 2 pi square, right? And this is 2 times 2 pi square, that is equal to 4 pi square. So viewers, the value of this integral is equal to 4 pi square.